Hello, welcome to another edition of TutorTube, where Learning Center's lead tutors help you understand challenging course concepts with easy-to-understand videos. My name is Kelly Schmidt, lead tutor for Statistics Learning Center. In today's video, we will run through the process of conducting a multiple regression in SPSS. Let's get started. First, let's define our research question. In this example, we're interested in predicting a student's GPA based on their scores on 3 other tests: a test measuring self-confidence, a test measuring adaptability, and a test measuring IQ. Here we can see the data from 14 students who were given these tests, along with their GPAs. And notice that we have 4 numeric or scale variables here, not counting the subject identifier row. When doing regression problems, the first step is to identify our dependent and independent variables. In this scenario, our goal is to predict GPA, so GPA will be our dependent variable. All the others will serve as our independent variables. So next, we need to enter our data into SPSS. Since each row in our dataset represents the scores of an individual, or a single student, we can enter the data in columns as is into SPSS. Okay, and notice that when we first copy the data in, SPSS automatically labels the columns with var 0000 by default instead of our variable names. To change this, we can click on Variable View at the bottom to switch to a new window. From here, we can click on the var 001 label, which corresponds to our first column with the GPA scores, and rename it GPA. We can do the same for the next 3 cells with self-confidence, adaptability, and IQ. Next, we can specify the measures for each variable. Since all of our variables were numbers, not names or categories, these will all be coded as scale. Okay, so with that, we are ready to run our regression. Click on Analyze, and then Regression, then Linear. This will pull up a new window. From here, we need to first choose our dependent variable. Remember that since we're trying to predict GPA, it will be our dependent or response variable. Our independent variables will go into the independent variable box. You can move them one at a time or use Control plus Shift to highlight multiple values at once. Next, click on Statistics. Here we will want to select descriptives, part and partial correlations, and collinearity diagnostics. Descriptives will give you a table showing your summary statistics for each variable, the mean, standard deviation, and count. Part and partial correlations is useful for determining how influential each individual independent variable is, and collinearity diagnostics allow us to check and make sure that our assumption about multicollinearity hasn't been violated. Click on Continue, and then from here we can click on Plots. This window will let us make a couple of scatter plots that will help us to check our assumptions on homoscedasticity and normality of residuals. Use the arrows to move zpred into the x-axis box and zresid into the y-axis box. This will create a scatter plot plotting the standardized residuals against the standardized predicted values. Next, click on the boxes next to histogram and normal probability plot, and then click on Continue again. From here, we are good to go. We can click on OK. This will open up our output window with the results of our regression. At the top, we can see our descriptive statistics table with the summary statistics for each variable. Below that, we have a correlation matrix showing the correlations between each pair of variables. If we keep scrolling down, we can find the model summary and ANOVA table for the regression. If we want to go about interpreting this model, we should first look at the sig value for the overall test. Because this value of 0.027 is less than 0.05, we can conclude that our overall regression model using these three independent variables is significant, which means that the three variables together are able to predict GPA scores better than chance. Now that we know this, we want to know how good the model actually is. The R-squared gives us the percentage of variation in the dependent variable scores that's explained by the independent variables. Here we would say that 58.4% of the variation in GPA scores can be predicted or explained by a student's self-confidence, adaptability, and IQ. We can also get a lot of information from the coefficients table, including the coefficients needed to build the multiple regression equation. So be sure to pay attention to whether or not you're asked for the unstandardized equation or the standardized equation, because the coefficients used for each will differ. For example, if we wanted to build the unstandardized equation, or raw score equation, we would look at the values in this first column. Just like with a simple linear regression, we want to find both a y-intercept and a slope value for each of our variables. So we start with the dependent variable, GPA, with a hat indicating that the equation will give us predicted values. Next, we take the constant value, negative 2.851, and we leave that as is without multiplying it. Next, we add a term which has the coefficient in front of self-confidence, 0.022, multiplied by the variable. We do the same for each variable in the column to get the full equation. We can use this equation, this model, to predict scores on GPA if we have a student's self-confidence, adaptability, and IQ scores. Looking at the final column in the table, we can find our VIF values. We use these to check our assumptions on multicollinearity between the independent variables. Here, all of our values are pretty close to 1, which is good because it tells us that multicollinearity is low and our assumption is met. If these values are bigger than 5, you might want to reconsider your choice of independent variables. Finally, we can calculate our structure coefficients to determine which of our independent variables contributes most to the model. So for example, if we wanted to calculate, let's say, the structure coefficient for IQ, we would use this formula here. R sub IQ is the zero order coefficient or correlation for IQ, and R is the correlation coefficient for the full model. We can find the zero order correlations in the coefficient table and see that the value for IQ is 0.745. The R for the full model can be found in the model summary table at 0.764. Dividing these, we get a value of 0.975 for the structure coefficient. In order to interpret this value in context, we square it first, which this gives us a value of 0.951, or about 95%, for the squared structure coefficient for IQ. Now we can use this to say that about 95% of the variation in dependent variable scores that was explained by the model was accounted for by the IQ variable. This is a pretty high value, which tells us that IQ is probably a significant predictor of GPA based on this data. And of course, there's more to interpret with an analysis like this, but we've gone through some of the main concepts that'll be helpful when you're going through your coursework. So thank you for watching this TutorTube presentation. I hope you enjoyed this video. Please subscribe to our channel for more exciting videos. Check out the links in the description below for more information about the Learning Center, and follow us on social media. See you next time.